So let me start with the prism today. So now refraction through a prism. Is it visible, right?
Yes.
Okay. So what is prism basically? See, prism. So this is a prism ABC, okay? ABC is a prism. BC is the base of the prism. AB, AC are the two inclined surfaces of the prism where they basically do the refraction. Okay, AB is the refracting surface, AC is the refracting surface. Okay, BC is the base of the prism, and this is the angle of the prism. So A is the angle of the prism. What is prism here? It is an optical medium bounded by three rectangular faces and triangular faces, which are parallel to each other. This is the definition for prism. It is an optical medium bounded by three rectangular faces and two triangular faces which are parallel to each other. Is it clear?
Yes.
Can you people please write it down? Yes, Agarwal.
Yes.
Is it over?
Yes. Yes.
So here AB and AC are the two refracting faces. BC is the base of the prism and A is the angle of the prism. Clear? Here optical medium is the medium where the light can pass through it. So basically prism is made up of a glass. Let me redraw the prism diagram. So this is the prism A, B, C. Clear? BC is the base of the prism. A is the angle of the prism. Okay, we'll make it here. Write it down. A is the angle of the prism. Now what I will take? Let us take a source of light. Okay, from the source of light, incident light, refracted light, emergent, right? This is the path of the light ray. Okay, so here, along with that, we'll take the normal. Normal which is drawn on the surface AB and AC. So here PQ is the incident ray, QR is the refracted ray, RS is the emergent ray, here is I1 is the angle of incidence, I2 is the angle of emergent, R1 is the angle of refraction, R2 is the angle of refraction. Okay, you can write it. PQ is the incident ray, QR is the refracted ray, RS is the emergent ray, I1 equals angle of incidence, I2 equals angle of emergent, R1 and R2 are the angle of refraction. Are you people noting down?
Yes, sir.
MN is the normal, ON is the normal, MN is the normal, ON is the normal. Okay, it's all about the different the parts of the diagram. Is it clear or not? PQ is
Yes,
the
sir, it's
incident
clear.
light ray, QR is the emergent light ray, RS is the emergent ray, QR is the refracted ray, PQ is the incident light ray. Clear? So now just imagine there is no prism. If there is no prism, what will happen? Light would have gone in the straight path. Is it right or not? Light would have gone in the straight path, correct? So because of the prism, light is getting deviated and which is going like this, correct? But the person, just imagine who is standing here, for him, light looks like it is coming from somewhere here. But is the light is coming from here? This ray RS is coming from this point. Let us call this as a point T, and this is call it as a Z. So can you people see this what I am talking about here?
Yes, sir.
So
Yes, sir.
PQTZ is the light supposed to travel in the absence of prism. Due to the prism, light is getting deviated and it is going out like this. Write it down. PQTZ is the path of the light in the absence of the prism. And this angle is called as angle of deviation, small d. Is it clear? So D is the angle of deviation. This is all about the diagram, bro. Any doubt you can ask me here. If you have any doubt, you can ask me. Shall I go to the next slide?
Yes, sir. Yes.
Is it clear? So A is the angle of the prism, BC is the base, AB and AC are the refracting surfaces, PQ is the incident ray, QR is the refracted ray, RS is the emergent ray, PQT, that is the light supposed to travel in the absence of the prism. Due to the presence of the prism, light is getting deviated here and which is going via QR and coming out as a RS. And here we have to observe, normal is always perpendicular to the surface, which is making 90° here. Here normal is perpendicular to the surface, so making 90° here. Clear? You can add here.
Yes.
MQN is the normal, ORN be the normal, these are the two normals which is drawn on the surface AB and AC. Now the angle between ray PQTZ and TRS here. TRS, can you see here? TRS. What is the angle formed here? Called as angle of deviation. Clear? So I can directly write it here. Angle ZTR equals D here. Okay, ZTR is nothing but angle of deviation D. Clear? Next, can you people see the quadrilateral here? AQNR is the quadrilateral. What? Now we can write it as from the quadrilateral AQNR. Okay, we know that. What is the total angle of the quadrilateral? If you add 4 angles of the quadrilateral, what you will get? What is the sum of the 4 angles of the quadrilateral, boys?
360°.
360°, right?
Yeah.
Out of that, what is AQN? What is the angle of AQN and what is the angle of ARN? AQN equals ARN. What is the angle between them? AQN and ARN equals what? 90°, is it right? Because it is making perpendicular to the surface normal, correct? So here 90 and here 90 and another 2 angles are A and N, right? So now what we have to do here, shall I go to the next slide?
Yes. Yes.
Angle QAR plus angle QNR. Here you can see here QAR and QNR. If you add those 2 angles, we will get here 180°. But we already know that QAR is nothing but A and QNR is nothing but angle QNR equals what? Let it be same only. But now to find out this angle, we can take the triangle from the diagram. What is the triangle? Can you see the triangle here? The below part. QNR is a triangle, is it right? Out of that, we know this is the R1 and R2, but we don't know this angle, right? Let it be like that only. We know that from the triangle QNR, okay, R1 plus R2 plus angle QNR equals 180 degree, because sum of the three angles of the triangle will be always equal to 180 degree. So R1 plus R2 plus QNR equals 180 degree. Can you people see this? We'll call it as
Yes.
the equation number 1. We'll call it as the equation number 2. Now compare 192. If you compare 192, what we will get? Can you see the equation? A plus QNR equals 180. R1 plus R2 plus QNR equals 180 degree. Is it right? So in the place of A, we can see R1 plus R2, right? So now compare 192, then we will get, we can write it as A equals R1 plus R2. Is it right? From these two equations, in the place of A, we have R1 plus R2. Correct? Let us call it as the equation number 3. Now we'll go back to the diagram again. See, D is the angle of deviation. Again, can you see the triangle here? TQR is a chota triangle here. So, and D is the exterior angle of this triangle. Is it clear? D is the exterior angle of this triangle. Then I can write it here. Okay. Angle ZTR is nothing but TQR plus angle TRQ. You go back to the diagram so you will understand. See here, D is the exterior angle of the triangle, and interior angle of the triangle are what? Here we have. So that I have written here. Exterior angle will be equal to the sum of the internal opposite angle of the triangle. Correct? So we know that ZTR is nothing but D. D stands for angle of deviation. Then how we can take here? TQR can be taken as what? R1 minus I1. Can we take it like that? So we can take it as I1 minus R1 plus I2 minus R2. Is it clear or not, boys? These are the two angles. If you subtract that, we will get these chota angles here. Boys, is it clear or not?
Yes, sir. It's clear.
Now D equals what? We'll remove the bracket. I1 minus R1 plus I2 minus R2. So we can rewrite it as I1 plus I2 minus, let us take minus common outside. So R1 plus R2. Is it clear?
Yes.
Let us call this as a fourth equation. Are you people writing down?
Yes, sir. Yes, sir.
So D equals I1 plus I2 minus, from the third equation, what is A equals R1 plus R2, right? So in the place of R1 plus R2, can we write it as A? Because we know that R1 plus R2 is nothing but A, right? So now I'll take this A this side. A plus D equals I1 plus I2. Why there is no response? Is it clear or not?
Yes, sir. Yes, sir.
Let us call it as a fifth equation. Write it down, Ra. Shall I go to the next slide?
Yes, sir.
Shall I go to the next slide?
Yes, sir.
And we have to remember one thing, Ra. When angle of incidence increases from 0 degree. Let us increase the angle of incidence from 0 degree. We'll start the angle of incidence as a 0 first, then 1 degree, 2 degree, like that we are keep on increasing. Okay, when we increase the angle of incidence from 0, the angle of deviation first decreases and it will reach us minimum value. It will reach us the minimum value, and again increases. Okay, so this is the theoretical part you have to remember. When the angle of incidence increases from 0, first the angle of deviation keep on decreasing and it will reach us the minimum value, then again it start increasing. Okay, it can represent with a chota graph also. If you want, you can write it down. So let us mark it as 0 here. Y axis, x axis. Okay, initially what will happen? The angle of incidence is keep on decreasing, and when the angle of deviation is keep on increasing, okay, it will become minimum, then it will keep increasing. Okay, so this part is taken as x-axis is taken as angle of incidence, okay, and y-axis is taken as angle of deviation d. So you can see the graph here. You can use the scale and make it straight. So we'll call it as a I1. We'll call it as a I. And from here also you can take like this. So I'll call it as a I2. So this is the angle of incidence and this is the angle of emergent. We can take it here. Okay, so this is the graphical representation. Okay, shall I go to the next slide?
So could you go to the previous slide, sir?
In this case, the minimum deviation minimum or least deviation is called as angle of which is the minimum value here. We can see here That is called as angle of minimum deviation. So this is D, and we'll take it as a D here. Okay, the minimum value when the angle of incidence keep on increases from 0 to the higher values. At certain point, what will happen? The angle of deviation will become very least. Further from that point, it will gradually increases. So when it becomes 0, right? I mean, when it when it become minimum, not 0, when it become least value out of the all values, that point is called angle of minimum deviation. Shall I go to the next slide? And when you go to the first slide here, we know that I1 is the angle of incidence, I2 is the angle of emergent, right? We know that these two angles are interchangeable because light has the property of, the reversibility. So it will retraces its own path. If you may allow the light to go back in this path, so it will go with the same angle and it will come out with the same angle only. So what we can say here, boys, are you able to understand?
Yes, sir.
So angle of minimum deviation has two values. So instead of saying that, I can say that I1 equals I2 equals I, because both are same angles. Let us say that it is hit the surface with 30 degree and it will emerge out with the 30 degree only. Getting? So then the angle of refraction R1 equals R2 equals R only. You can call this as a star. But we already know that in the third equation, A equals what? R1 plus R2, right? So this equation will become now equation 3 can be, okay, rewrite as A equals R plus R, because R1 equals R2 equals R only, right? So we can write it as 2R. Then R equals what? A by 2. I'll call it as a fifth equation. Is it clear?
Yes, sir.
Next, when come to the fifth equation, what fifth equation says here? A plus B equals I1 plus I2. But we know that I1 equals I2 equals I, right? So that can be written as A plus D. Okay. The D can be written as capital letter D also. Okay. I plus I equals 2I. So now what will happen here? A plus D equals 2I. Then I equals A plus D by 2. Is it clear? So I'll call it as a sixth equation. Right? From Snell's law, we can write it as, for refractive index, N equals sin I by sin R. Call it as the seventh equation. This is the expression we got from the second laws of refraction. That is nothing but Snell's law, right? So shall I go to the next slide?
Yes, sir.
So go to the previous page, so
Yes.
no, so the page before this, I just need to check if I missed a point or not.
Yes.
So no, one second. Can you go before this as well? Sir, can you go to the diagram? Then just 1 second, please. Yeah, yeah. Can you go to the next page, sir? Yes, sir. Can you go to the next page?
Is it clear?
Yes, sir. And the next page, please.
I mean, new slide.
Yeah, that's it, sir. Okay.
Now we can use fifth and sixth expression in the seventh expression. Okay. Now use this fifth and sixth. Seventh. So now what will happen? N equals sine I by sine R, right? So N equals sine I. I means what here? A plus D by 2 whole divided by sine A by 2. Okay, you can put in the box. So this is the formula to find out the refractive index of the prism. N stands for refractive index. This is the expression for the refractive index of the material of the prism in terms of angle of prism and angle of minimum deviation. This is the expression for the refractive index of the material of the prism in terms of angle of the prism and angle of minimum deviation. Shall I go to the next slide?
So 1 second.
Yes.
I'm just
Sir,
noting it down. So 1 second.
yeah, sir. And after that, sir, since the meeting is about to end, could you just go to the previous slides? I need to take the screenshot, sir. So just I'll take it from the diagram, sir. Just can you go to the diagram page?
No problem. I have saved it. Let me share with you. Next. Okay. You can take it as a note. Okay. A thin prism or prism with small angle. Okay. Prism with small angles. Then the expression will change. Okay. Sine A plus D by 2 whole divided by sine A by 2. Correct? So when we say that the small angle, we can neglect this sine. Okay, so they will get cancel each other. So I can write it as n equals A plus D by 2 whole divided by A by 2. Correct? So when you take it as a inverse, okay, so A 2 and 2 will get cancelled. So n equals A plus D whole divided by A. So now what will happen here? It will get cross multiply. N A equals A plus D. Is it right?
Yes, sir.
So now you can keep it in the box. Okay. Furthermore, what I can write is NA minus A equals D. I'll take A this side, so plus will become minus. So now D equals, I'll take A common outside, N minus 1. This is one more important formula to find out the angle of minimum deviation. Is it clear?
Yes, sir.
So these are the different formulas will be useful for solving numericals in competitive or in the board part. So you can put it in the box. So here N stands for refractive index of the prism. I hope it is clear, right?
Yes, sir.
So all right. So let me end this. Thank you very much, Ra.
So could you please share this
Yeah,
PDF
definitely.
after?
I'm going to share it.
Yeah, so because 1 or 2 pages I couldn't write the notes.
Oh,
so-
yes, sir. Even I didn't do the second page.
Yes. Which page you are talking about?
So the second page, and I'd like to check everything too.
Yes, sir, same.
Okay, Ra. I'll do that. Let me share the same thing here. Second page, right? Yeah, this one.
Yeah. Oh, no, the next one, sir. Yeah, this and the next one too. Oh, yeah, that's why I asked. I want to just cross-check everything.
So will you send the PDF after the class, or shall I can I take the screenshot
I'll
now?
share the same things in the next class.
No, will you send this PDF after the classes, sir?
Yes, exactly.
Okay, sir.